Hello and welcome to Chemistry with Miss Bennett. Today we are going to talk about scientific notation and how to properly write it. Now, one of the big misconceptions when kids see scientific notation, like I will give you an example, this number here. It's a very important number in chemistry and you'll learn more about that later in the year. But when I take a look at this number, some students seem to think that this is a math problem to solve. This is not a math problem. This is scientific notation. So when you see this times 10 and there's some kind of exponent there, that means that this is just another way to write a number. And it's not meant to make your life difficult. It's actually meant to make your life very, very easy. Because if you look at that exponent of 23, that means that this decimal place has to move 23 times. So it goes way out here. So you're dealing with a really big number. So scientific notation came about to easily write really, really large and really, really, really small numbers. Now I know sometimes when we practice, we may not be using ginormous exponents. It might just be like 10 to the 3 or 10 to the 5, but that's just really for practice. Technically, you could write any number in scientific notation and that's okay. It's just another way to write a number, but the reason we have it is because of really big and really, really, really small numbers. Okay, so how do you properly write scientific notation? So here are the rules. All right, so rule number 1 is that the entire, in caps, right? So it means really important. The entire number, I got to write the to the left. There we go. To the left of the decimal must be between 1 and 9. So that means the entire number. So if we look at the number that I wrote up here before, the decimal place is there. So the entire number that's to the left is 6. Also, for example, if I wrote a number like this, the entire number is 105. It's not 5. The entire number is 105, which is not between 1 and 9, which means this is wrong. You would not write that. So you have to look at the entire number, and it must be between 1 and 9. If the number is not between 1 and 9, so let's see. If it is not, then move the decimal. So you're going to move the decimal to make sure that the number to the left is between 1 and 9. All right, so that's rule number 1. That's the hardest step. The rest of it's pretty easy. You're going to add times 10. And I put that in quotation marks because it's exactly that. So you're going to add times 10. That's what you're going to write down on your piece of paper after you've moved the decimal place, if you have to. All right, number 3, you are going to count the number of spaces the decimal moved. This number of spaces will equal your exponent number. So if you have to move it 2 times, then your exponent is 2. If you had to move it 3 times, then your exponent would be 3. So however many times you need to move, however many spaces you need to move the decimal, that's going to be your exponent number. And then the last step is the sign, like SIGN sign, whether it's positive or negative, the sign of the exponent. Now there's several different ways of doing this. And over the years, I've kind of changed the way that I do or explain this part probably 4 or 5 times. And I feel like this current way is the way that causes the least amount of confusion for students. So this is what I'm sticking with for right now. Once you are proficient with scientific notation, you will easily be able to just look at the number and you automatically know whether the exponent should be positive or negative. But until you get to that point, let me just give you a quick rundown. So to determine the sign of the exponent, whether it should be positive or negative, is you're going to look back at the whole number. Now the whole number is the number that's not written in scientific notation, and I will give you an example of that in just a second. But if your whole number is greater than 1, then you're gonna have a positive exponent. If the whole number is less than 1, then you're going to have a negative exponent. Okay, so let me show you what I mean by what are you looking at when you're talking about a whole number. So, I mean, I'm sure you know what it is, but just to have a clear example of what you're supposed to do. I'm actually, before, excuse me, we start writing this, I want to make sure we're clear about one thing. These are rules for writing scientific notation. So these rules would apply in any class, be it a math class or a science class or anything like that. Now, the thing that makes it special about being in a science class, you must stay true to your sig figs. So that may not necessarily apply in your math class. You might have to talk to your math teacher about that. But for chemistry and physics, or even biology, if you have to do this, you've got to stay true to your sig figs always. So you can never change it. And I will show you exactly what I mean by that in this example, or these next few examples. All right, so I'll set this up like a table. So we're going to have a whole number, and then we'll have a scientific notation number. I'll just abbreviate it SN because I don't feel like writing it out. And then keep up with your sig figs always. So in the one worksheet, if you're in my class, the one worksheet I've given you is set up this exact way. If not, if you don't have a sig figs column, you can easily just jot them down in the margin, but you must always keep them the same. You can't change them. So our whole number, underline that, there we go. Our whole number, let's say we have something like 23,400. Okay, and I need to write this number in scientific notation, and then I also need to ultimately figure out how many sig figs I have. I actually should do this first. I should figure out my number of sig figs before I start trying to write it in scientific notation. That way I don't have to go back and redo something. All right, so our sig fig rules, which if you don't know how to do that, I have another video on that. You should go watch it. But when you look at this number, 23,400, there is no decimal point written. So that means we're going to start on the right-hand side of our number, and there are 3 sig figs. Again, if you don't know how to do that, check out the other video that I have for sig figs. Oops, that should be an S, my bad. All right, so now that we've determined that we have 3 sig figs here for our whole number, that means I'm going to have 3 sig figs here for my scientific notation number. So I must always stay true. So whatever digits are significant, like in this case, I have a significant 2, a significant 3, and a 4, and the zeros are not. Any number that is significant gets written in the scientific notation number. Any digits that are not significant, and that's going to be the zeros, then not all zeros, but if they are insignificant zeros, then I will not write them. Okay, so now with all of that being said, let's clear up some of this so we can easily see. I'll just rewrite it real quick. 23,400. All right, this is a comma, not a period. So what I need to figure out is I know there's no decimal point written, and this number it's hidden, and we know that it's right there. So that's where the decimal place is. The entire number to the left of the decimal is 23,400. That is not between 1 and 9. That's 23,400. So that means I need to move my decimal place in order to get the entire number that is to the left of the decimal exactly where I need it. And you'll get to be really good at this, like really fast. You know that if I move it here, the entire number is 2,340. There, the entire number would be 234. There, the entire number to the left of the decimal would be 23. One more. If I put it right here, I know that the decimal place has got to move right here between the 2 and the 3, because that means the entire number that's to the left of the decimal is 2. And that is between 1 and 9. This right here, what we just did, is the hardest part. And then I need to start writing that number, 2.34. Remember, you only write the digits that are significant. So the zeros are not, so I'm not going to write them. And then step number 2, add times 10. Okay, so times 10. Step number 3, we're going to count the number of spaces that the decimal moved. All right, so we need to go back and check that out and look at how many spaces we actually moved the decimal place. So we moved it 1, 2, 3, 4. 4 times. So the exponent is 4. 1, 2, 3, 4. 4 times. Now, when I take a look at this whole number, the whole number was 23,400. And that is greater than 1, which means that exponent is a positive 4. You do not have to write the positive. It's assumed, just like in math, that it is a positive 4 if you don't write it. All right, so that's it. That's how you write numbers in scientific notation. All right, so let's practice another number. And I'm just cleaning this up a little bit. There we go. So let's practice another number. Let's try one that looks like this. 0.00300. Well, let's write this number in scientific notation. Okay, first thing with any number in science is determine how many sig figs you have. This number does have a decimal that's written. That means that these are my sig figs, 1, 2, 3. So I have 3 of them. All right, that's good to know, so I need that. Now, and if you need to kind of keep it marked so you can keep up with who is significant, that's fine. I'm just trying not to have too much writing on the number. All right, these digits are significant. The 3 and the last 2 zeros are. Now, we're still on step 1. The number to the left of the decimal is a 0. That is not between 1 and 9. So I need to keep moving this decimal place, and there's still currently zeros until I move it right there between the 3 and then the 0 that's directly behind it. That means the digit to the left of the decimal is between 1 and 9 because it's a 3. And I do not write these zeros in the front. Why? Because first of all, this doesn't make any sense, number 1. And number 2, they're not significant. So you're only writing the significant digits when you write a number in scientific notation. So it's 3.00 because those are the significant digits. Times 10 is step 2. Let's count the spaces we moved it. Let me get a different color. Okay, we go 1, 2, 3. We moved it 3 times. And this whole number, which was this number is less than 1. So since it is less than 1, this gets a minus sign. It's a negative exponent. All right, kids, have a good day. Thank you.